Okay, level 4. Ooh, yellow. Level 4, number 1. Let's switch into a different color that's not so hard on the eyes. All right, now this is an interesting question. It's the mailman. What you have here is a mailman and a person that he collides with. And then there's the additional sort of thing about this letter bomb that's going to explode. Okay, so let's describe the situation at the beginning. Initial situations. Initial. You have a mailman moving 5 meters per second west. So here's the vector that shows the mailman's velocity, right? And that would be due west. So we can put a little. And then he collides with another man moving 10 meters per second east. So the other man is moving east. So this is the mailman, which we're going to use an M for. And the other man, let's just put P for the other person, just so we don't get confused. Actually, let's not use P because of momentum. What would we do? Let's call this other man the victim. He's the V, the Vic. That's going to be speed. No matter what letter we use, we're going to have problems. So pick a number, pick a letter for our subscripts, right? Mailman and the victim of the collision. Okay, 3 meters per second. No, 10 meters per second. Got to make sure I get that right. 10 meters per second east. So here's him. Now this is nice because it's not 2D, right? It's a nice, actually it's 2D, not 3D I meant. It's not one of these crazy things. So what we need to do is we need to figure out momentums, right? These velocity vectors can be turned into momentum vectors by multiplying by mass. So we can change the 5 meters per second to a momentum vector by multiplying 80 times 5, or 400. And we can change the one that's going east by multiplying the mass 60 times 10, or 600. All right? Now, here's what we have to work out. The total momentum before equals the total momentum after. This is always the case. And before, it's pretty easy. We have the momentum of the mailman and the momentum of the victim. But what do we have after? Well, after, we have also a mailman and a victim. You might be confusing the bomb questions we did before, where pieces of the bomb exploded outwards, and you might think, well, where do the bomb pieces go? But you'll notice the question isn't really telling us anything about pieces of the bomb. It says the letter bomb actually has negligible mass. So it's just going to blow up, and what it's going to be doing is just going to be adding additional velocity or energy to the situation. But there's still going to be the momentum after the equation. The momentum still have to somehow balance out. Okay? So when we do the momentum after, the momentum of the man after, okay, there is no additional momentum to this particular question because the letter bomb has no mass. And without a mass, remember, momentum is mv. Without a mass, you can't have momentum. So the letter bomb is not contributing any additional momentum to this situation. So we don't need to include it in our equation. All right. So that's one thing that you have at your disposal. The other thing you have to work with, though, is the problem that these momentums after are now in sort of a 2-dimensional array here. One mailman goes due south, and the other one is the other person, the victim, going 15 degrees east of north. Okay. Now the question says, how much has the kinetic energy of the two men increased? But in order to do that, we're going to need to figure out their velocities, right? So what we have here is the mailman, which was 600, and because it's right, let's write it in here. 600. Oh, I'm on the eraser. 600, right? And we'll give that a velocity. Let's go back. It was 600. Oh, that's not the mailman. Sorry, the mailman is 400, right? 5/8 are 40. Yeah. So the mailman is, let's keep it in order. The mailman is 400. And the mailman was moving due west, which is 180 degrees. And we have the victim. He's the one moving 600. And he's moving his east, right? Due east, so 0 degrees. Now, here we have MV, so mailman, 80 was his mass, V prime. And we don't know the V, but we do know the direction of the mailman. That's kind of important when we set up our triangle. He's hurled due south. So he has to have a direction of 270 degrees. And then I'll just jump down here to the other one. We have the other man whose mass is 60 and V. I should put a M here for this one and the victim's velocity this way. And we also know he has a direction. He's being hurled 15 degrees east of north. So 15 degrees east of north is 15 right there. So that's basically 75 degrees in standard math. All right, so how can we solve this? Well, on the left side of the equation, because it's linear, it's back and forth, we don't need to do a triangle. Because this is east and west, we can assign a negative to the 400 and a positive to the 600, and we can figure that out, and it would become 200, right? And that would be 0 degrees. And then we have this one, 80, velocity man, plus 60, velocity victim. Oh, I'm sorry, I forgot the directions. Better put those in. I'm trying to save space, but it's not working. We've got to put the 270 in there. Plus 60, velocity at 75. All right. Now you might think we can't solve this because of the two different V's, but let's draw the triangle. What we can do is move here's an interesting thing that you can do with triangles, vector triangles. I'm going to just give you a quick lesson here. Remember how if we said that this vector, and we put them tip to tail, plus that vector equals this vector? Okay, well what if we did this triangle? What if you take a vector like this, and a vector like that, and a vector like that? So tip to tail, tip to tail, tip to tail. If we call all these vectors A, B, and C, this triangle represents, or is, A plus B plus C. And if you think about it, we started down here. We went up and over and down. We ended up back where we were. Which means, if we end up back where we were, the net result is nothing. So when you draw a triangle where everything is tip to tail, it has to equal 0. There's no other way about it. So up here we have three triangles, or three vectors in a triangle. And we can set it up so that one side equals 0 by moving this 200 degree vector over to the other side. So let me do that. Let me erase this stuff below here that I just drew. That's why this is level 4, by the way. You kind of have to think about this. So now I'm giving you this hint. All right, so move it to the other side. 0 equals, and then you have the 80 V prime 270 plus 60 V prime 75. And then what will this become when you move it to the other side? Well, when you move it to the other side, it's going to become a negative. So a negative 200, 0 now becomes adding a 200 at 180. Remember how we do that with reversing the direction of a vector. Okay, so now you have to draw a triangle, right? And so what you draw is 80 at 270, right here. So there's the 80. Then at 75, you draw the 60. But be careful. Only go this high because this last one has to be moving due west, 180. So there's my 200, which has to be 180. Here's my 75, which is actually 60 V victim. And over here is 80 the mailman prime. Now, do I have any angles? If I play with some angles, by looking at these, I know that the angle down here is going to be available to me because we said that he was moving at 75 degrees right there, which means this internal angle is 15 degrees. So guess what? I have a right triangle because 180 and due south makes a right triangle. And in this right triangle, I have an angle of 15 degrees. Now I can set up trig ratios. The sine of 15 is going to equal something interesting. The cos of 15 or the tan of 15 can all be used to figure out ratios that will involve the 200, a constant number, and this side, or the 200 and the constant number on this side, and make them solvable. So because of the cool nature of vectors, you see here, when you have vectors that add to 0, here's the rule. Any vectors adding to 0, when you have 3 of them, they must form a triangle, a closed triangle. Now, if you had 4 vectors or 5 vectors, they would also form a closed figure, but it wouldn't be a triangle, and it's much more complicated. So when you only have 3, it's nice and easy. So remember that. Write this somewhere ingrained in your brain, that 3 vectors adding to 0 must form a closed triangle because they all have to be put tip to tail in order to add. So if you look at the mathematics of this, if you're adding the vectors, that means they all have to be tip to tail. So no matter what, start here, there's 1. Now tip to tail, here's the other one. If they add to 0, they must get back where they started. So the other one must go here, tip to tail, and you must get back where you started. And it doesn't matter where you go with this. You could do it any way you want. Whoops, that didn't work. There we go. See, any triangle, no matter where you start, if all 3 are tip to tail and you end up at 0, you have to be back where you started. So there's 2 key things. There have to be 3 vectors. You're adding them all, and they have to add to 0. So you can create a situation like that when you have something like this, which looks unsolvable with 2 variables. By moving this term over to here, we create this scenario where 3 vectors add to 0, which makes us be able to draw a triangle tip to tail like this, and that's how you solve the problem.